So, in this session, we'll talk about the new improvements that I've done in Elasticsearch indexing and some live demo into how to analyze heap profiles, CPU profiles, and what sort of things to look into and that sort of stuff. So, let me start about talking on some of the improvements that I made to Elasticsearch indexing. There are three main improvements. First is the incorrect job progress. So this is a fairly common thing that you'll see coming up from time to time, like 104, sometimes 110, sometimes 99%, things like that. So this was due to an incorrect counting of our users' posts and things like that. So like our percentage calculation was sort of going off. So that was one thing which I fixed. And second, and a more important thing was now the Elasticsearch indexing job is resumable. What this means essentially is that, so we encountered this problem in our community daily servers, wherein every 24 hours, a new build of the master gets deployed, and therefore the job server gets restarted every 24 hours, right? Which means that if you have a job which takes more than 24 hours to run, that means that job will never finish, right? Because the server will restart. So essentially, like that job is like did not succeed, and then the job server will again restart it, and again it'll take more than 24 hours. Again, the server will just, so essentially it will never finish, right? So what I did was that so the indexing works in batches. So what I did was I stored the state of each batch into the database, so that whenever whenever the server is restarted or it gets suddenly shut down, the state is stored. And then when you restart the server, the indexing will happen from that point onwards. So, but you might ask that, wait, does that mean that I can never manually cancel the job? No, if you press the cancel button, that the cancel workflow is untouched. So yes, you can cancel the job. But if you restart the server, then the job will be paused, and then it will resume when you start the server. So if you want to manually cancel, then press the cancel button. Otherwise, by default, the behavior is to resume the jobs. Okay. And then the final and the most important one is that I have rewritten the entire indexing logic to be much more efficient now. So what were the changes? So this is what I demoed in the R&D meeting, but that was within 3 minutes. Now I have much more time to explain things better. So assume this as your timeline of the posts, right? Let's say that this is T0 and you have a post get inserted, and like this is the the latest time. Now you want to index all of these posts into Elasticsearch, right? So what the previous method did was it had a batch window time interval, and that you could configure that in config.json, and it would pick up posts in that interval, and how many posts it would get, it would index that into Elasticsearch. So that was like a single batch, right? But there is a problem with this. The problem is that this sort of logic, it assumes that there is a constant number of posts generated in that interval, right? So let's say that interval is like 1 hour or 12 hours, 6 hours, things like that. So it assumes that within this 6 hours interval, the number of posts are kind of constant, or like in average, it assumes that it will turn out to be the same, right? But in reality, that doesn't happen, right? So let's say that here I have a post table wherein you have the first post here, then 3 posts here, and then the fourth post is here. But with the previous logic, then only the first batch will get 1 post, second batch will get 3 posts, third batch will get 1 post, and then and you can have more batches, which would CPU would just get wasted, right? It will because see, each of these batches needs a database query, right? So it will make a database query from time tx to ty. It'll say that, oh, no post. Then again, it will try another query from ty to tz, no post, right? So this sort of logic is not super optimal. what I did was I changed the batching logic to move from a time-based window to a post window, right? So now I am taking batches of posts by counting the exact number of posts. So irrespective of however way your post, let's say that, first initial month you have a lot of posts, and then you don't have much posts, and then suddenly third month you have more posts. So irrespective of however way your posts are generated, now the new batch size is the number of posts. So in your config.json, you can specify that, okay, like per batch, I can index 10,000 posts, right? 10,000, 5,000, doesn't matter. But always that will be constant, right? So which means that the amount of posts you are indexing to Elasticsearch remains at a constant workload, and you are not redundantly making database queries, right? So that gave us a lot of improvement. And like, yeah, with the latest support ticket, I think the customer mentioned it finished in 3 minutes rather than 12 hours. So yeah, this was one. And now I want to talk about the debugging improvements, right? So previously you would start off an indexing and then like it'll suddenly stop in the middle. You don't know what's happening. Now there's much more debug info captured in the data column. So by the way, this is the database row. And so in this data column, for every batch, it will count that, okay, like how many channels are indexed, how many posts are indexed, how many users are indexed, everything. So if it crashes in the middle or something, some error happens, you can ask the customer that, hey, can you please show me the database row for that Elasticsearch job? And then if you can capture this one and send it to the developers, then it gives us a much more idea that, okay, like where the posts indexed, where the users indexed, then like if so let's say that, okay, it said that done channel counts is 56,000, right? Then I can ask the customer, hey, can you tell me what's your total channels? If the customer says that, okay, like it is 56,000, then we know that, okay, channels were indexed, then maybe users were not indexed. So maybe that way we know that, okay, where did it fail, right? And then like basically all sorts of things like this start post ID, start user ID are the start of the batches, right? From when did it start the next batch, right? So that's basically, so this line is for our the reindexing for our entire community database. So basically you can see 7.5 million posts, 15K users, 56K channels, and 1.2 hours. So pretty decent. And so I think this is about it. Okay. Any questions so far here?
I have two questions. This log here, is this a debug level log?
No. This is in the database. This
is a database log.
Yeah.
Oh, okay. I thought this was a log. So this isn't going to be output to the Mattermost.log, right?
No. So this is this is a row in the jobs table, right? So every job you start, it creates a database row, right? So this, like the type is Elasticsearch, post indexing, created, starter, all that start up there. But this data, the data column will contain per batch. Every time we process a batch, this data column would be updated with the number of posts that got indexed, right? So like it shows the final posts here, which is 7.5 million. But initially when the job will start, it will start from like 0, 10,000, 20,000, things like that. So yeah, anytime the job crashes in middle or some error happens, then you can just capture this data column, and then it's very for us to identify where it has gone wrong, how much has it really indexed versus, oh, I don't know if it didn't index at all, or it indexed to 99%, suddenly it stopped, things like that.
Okay. So follow-up question, is there any way maybe one day to have this in the Mattermost log, just because that's easier to capture from a customer's perspective?
Yeah.
Instead of a query.
Mattermost log, it's already, I think I'll need to check. I'll need to check, but yeah, of course, yeah, it's okay. So basically what you're asking for is that as and when a batch is getting processed, I'll just output a debug log that, hey, I indexed this many number of posts and that's it, right? Something like that.
Yeah, basically what you have here in this data column would be phenomenal.
Right. So, but this is like an aggregate thing. So this single row gets updated every time a batch is processed, right? It does not capture the whole historical update of every time a batch is processed. But if I do it in the logs, every time a batch is processed, you will get a new log, right? So that's the difference.
Okay.
Maybe that could be done, like, for example, with the LDAP or SAML, where we have the SAML trace option that you can like toggle if you need it.
Yep.
That would be cool. Yeah.
So next question, then I'm done for now. So I see start post ID, user ID, all that fun stuff. What is the order? If we're starting there, is the order create at when we look at the table?
Yep.
Okay.
Yep. So it starts from created, and if I have multiple posts with the same created, the order is post ID, which is basically random. So yeah, we don't care about the order of posts in the same millisecond, but just to have a constant order, we sort by the post ID. Yeah.
Perfect. Thank you.
So I have a couple of more general questions. And I'm trying to say it, I don't want to sound harsh on the product, but we seem to leverage a heck of a lot with Elasticsearch. Should we have I'm just wondering whether we should expose how much customers don't get by not having Elasticsearch. I mean, we always tell them, oh, millions of posts here and there, you should have it. Is there a deeper detail on what you miss out on? Because of it.
Right. So yeah, I guess like it's slightly unrelated, but yeah. So the thing with database search is that searches in database are not very optimal. Like there is so many edge cases that you need to handle. Like I can search in the developer server channel. There are lots of edge cases, especially with MySQL search. Like there is a minimum word limit or something like that, and it does not search like the search functionality, like the way Elasticsearch understands what you want to search and the way it gives the results is much better than anything.
Yeah. So that's the kind of stuff from a sales point, it would be great to highlight just really how good our search can be. So yeah, it's not a deep dive, but from a job perspective, it doesn't, like, if somebody wanted to write their own job, A, could they? B, why would they? And C, what is it documented? I guess I'm curious how user and developer friendly the API, the job framework is. I'm thinking Platform One. They have a lot of jobs that they run. Colton knows one that they're going to start running in June. I don't want them to run it, but they're gonna.
So right now, I don't think, like, if you're talking about a plugin, there's no way to write a job from a plugin. But yeah, you need to manually edit the code, add the job, and do that. So yeah.
Okay, so it's still not end user developer friendly. Okay.
That's true. Yep. Okay. So right. Hopefully this font size is good enough. Let me know if you want me to increase. So what I will do is I'll go through 3 profiles. I'll just walk through how to analyze the profile and how to understand different parts of the profile. So the first one which I want to go through is this one. So there was an issue wherein if you do an at all mention in a channel like Town Square or like a channel with so many channel members, then it would create like an out of memory issue. So what I think Marco was working on that. So basically I asked Marco that, hey, can you please capture a heap profile and send it to me. So this is that heap profile, and I want to show how to figure out what is going on. So first things first, so you need to have the Go toolchain installed. And then whenever you want to analyze a profile, you would want to do something like this. Go tool pprof. You could do all mention. So it will just open the CLI, but there is a unappreciated flag, which is HTTP. Always, without thinking anything, always open the web UI. So this is the web UI. Hopefully, can you see the browser?
Yes.
Okay.
Yes.
Right. So this is the heap profile. What are we seeing here? So first of all, let me explain some of the basic things of a heap profile. So here we can see Mattermost in use space, right? So what is the difference between alloc space, in use space? So objects are the objects that you have in your heap, and space is the total allocation, right? But the main difference is the difference between alloc space and in-use space. So in-use space will tell you how much space is allocated, is kept alive in the heap currently live, right? So things like this is alloc space is helpful to detect things like memory leaks or memory spikes or things like that. Sorry. In-use space, my bad. Did I say alloc space? It should be in-use space. And alloc space is only for allocations, right? Which means that it will allocate, but then garbage collector will take that, right? So alloc space is helpful for analyzing things when you have too many objects doing the allocation, when you have the garbage collector running too often. That means that is the so that is when alloc space is helpful. But here in our case, what we saw was that, okay, we are seeing that, okay, if somebody doesn't at all mention, then there was a huge memory spike, right? So that means we need to work with the in-use space. So, okay, with that done, so what are we seeing here? Basically, so a heap profile will give you like a full stack trace of the functions which are taking the most space in the heap, right? And the width of the arrow, the more wider or thicker the arrow is, that means that is allocating, that is taking the majority portion of the heap. We'll look at other profiles where this is kind of simplistic, where you just have a single stack trace, but we'll look at other profiles where you have multiple things and it's not very hard to understand which is taking the majority of the heap. So that time, then the width of the arrow becomes useful, right? Okay. So what are we looking at here? So we can see that, okay, there is this app method, and then it calls into some store methods, and then we can go down. So here we are seeing that, okay, 91 GB, which is basically 99% of the heap, is taken by this thing, right? So, okay, so what is our next step? So one thing that you need to know is, like, you can actually select and deselect this, right? So these are all blocks. And if you hover over this, you can see that, okay, apps and notifications function, essentially what's the same thing which is written here. So if you select this, and then you have other things here, right? So this is the graph view, and top view will tell you which are the functions that is taking the majority of the heap. Now, I want to talk a bit about flat and cumulative. So flat means the portion of memory taken just by this function and not other functions called from this function, right? And cumulative means the total amount of memory allocated by this function and any other functions called from them. So essentially, if you have increment mention count, and increment mention count calls receive message, that means and then there's nothing in no other line in increment count. Increment count directly calls receive message and nothing else, right? So that means flat will be 0, because there is no code just in increment count which allocates anything. But sum will be, and cumulative will be 91 GB, because everything is coming from receive message. And if we go to receive message, we can see that flat and cumulative is the same. That means the majority of the code that is causing the allocations is entirely coming from receive message, right? So this was the top view. Now, flame graph, I won't go into it right now. What I'll go is back to graph. Now we need to see that we have a overall idea that, okay, somewhere here in receive message, it's causing a lot of allocations. But now we need to dig a bit deeper. We need to understand what is causing those allocations. So what we can do is we can filter here. So now this needs a bit of knowledge about how the code works.
Hey, Agniva, sorry to interrupt. I'm just wondering if we could step back a sec. I just want to make sure I follow what leads us here. So maybe the first signal is what's going on with okay, you said it was the out of memory on the application server, right? We say, okay, out of memory on the application server. So we probe the running Mattermost process with the pprof tool, which is going to give us.
You captured the heap profile.
So we captured that heap profile, and so now this is what we're analyzing with the UI.
Yes, that's it. Yep.
Okay. Okay, gotcha. Good. Carry on.
Okay, I gave so there's this if you open Mattermost curl localhost 8067/debug/heap debug prof heap. So that endpoint, if you do a curl request, that will give you the heap profile, right? So this is essentially that profile.
Got it.
Now I'm analyzing that profile. I want to understand what is the thing that is causing this.
This all depended on let's say the next customer has something like this going on. The pprof needs to be run right at the point, when the issue occurs and they're sitting there before they restart the service.
Yes,
this needs to be run. So likely that's not going to be doable the first time around. So we say to the customer, okay, here's what you need to have ready to run as soon as you see this out of memory issue again, and then you send us the output of it.
Yep, exactly. So in this case, Marco was able to reproduce this locally. So that was easy because he could, whenever the memory spiked, he could immediately capture the heap profile. But if it's not reproducible locally, then you'll have to ask your customers to run this the moment you see the heap profile, the spike in memory.
Okay, gotcha.
Okay. So, right. And where was I? Yeah. So we just have a rough idea now that okay, there is something going on here, but now we need to understand what is that thing from the application that is triggering all of this, right? So what I will do is I'll select this and I'll select this. Now I know that.
Sorry, Agniva. I'm still sort of making sure I have my head wrapped around how we get to this point. But so in this file, this heap profile, that is the heap that spans all running Go routines. Is that right?
Yep.
Okay, so this is a roll up. We don't know how many different Go routines necessarily were spun up, but it's the aggregate across them.
No. So what the Go routines part is not really important here. So a heap profile is just a snapshot of the entire heap at that time, right? So So there is a slight difference between CPU profile and heap profile in the sense that CPU profile, you can specify for how long you want to profile it. Usually we specify 5 seconds or 10 seconds. So CPU profile will run for 5 seconds. So the profiler will find out how frequently is a function running on the CPU for that 5 second time, right? And then generate that profile. Heap profile is very instantaneous. So the moment you take a heap profile, it will take the instantaneous snapshot of the heap at that time, right? Which means that you can take a profile one, and then 5 seconds later, you can take another profile, right? You can even compare the difference between two profiles and see how much the allocations increase or decrease, things like that. But heap profiles are always instantaneous. Whenever you see a memory spike, you take a heap profile, it will capture the whatever is there in the heap at that instance.
Okay, so we've got a running Mattermost server here. I guess I'm trying to wrap my head around how that's the only call chain we see in the heap profile.
So that's different. So what you are thinking is CPU profile. That this is not CPU profile. This is only heap profile. So it goes through the heap. Okay, it goes through the Mattermost memory and it analyzes what functions called such a things to accumulate in the heap, right? So it knows that 99% of the heap is coming from a buffer that is coming from this function, right?
Sure, but what I'm trying to understand, like, would there not be like a huge network? Shouldn't this be a spider web? Maybe most of it is concentrated in this particular line, but a running server is going to have, like, if you scroll up.
So see, this is like 99 so this is 91 GB, right? So which is like a huge thing. The rest of the server is just like 100 megabytes or things like that, right? So it's like in comparison with that, the rest of the server is nothing. So what you can do is like you can take a heap profile on a running Mattermost server, then you can see, right? I'll show you another heap profile. It'll be much more clear. Right?
Okay.
Let me show you right now. So this is another.
I'm just thinking surely that server was running. Okay, that's sort of what I was thinking. I would have more like what I would have seen. Yeah. Okay.
But now the problem is you are not exactly sure where is the spike coming from, right?
Right.
Because there is so many things like, okay, so this is what I was saying, that sometimes the arrow will be thicker, sometimes it will be very thin. This is like medium, this is very light, this is very thick. But probably this is what you are expecting, right?
So how did you, like, why are you seeing one with only a single chain? Did you do something with the pprof tool to isolate to the heaviest one?
This is just how the profiler works. Profiler will see how much of the heap is being consumed in a majority. So it saw that 99% of the heap is accumulated by this thing. So it will just capture that. Right.
Okay.
Here you can see that, okay, this is captured by 58%. So that means it knows that, okay, there are other portions of the heap also that I need to capture, because 58% may not be enough. So this is like 58%, and then this is 29%. Now with 58 and 20, now it's okay, like now I have captured majority of the heap, but maybe I'll capture a bit more here and there and there. And then like whenever it's close to 97, 98, it will stop capturing. It won't capture everything, because it knows that we are looking for a spike, right? We are looking for a memory leak. We don't need to know everything that's there.
Okay. The tool's doing that, has that intelligence. Okay, got it.
Yep. Cool. So
Agniv, a really quick question. You mentioned an endpoint for Mattermost to capture the profile. What is that endpoint?
I'll send it to you in chat.
Okay, perfect. Thank you.
Right. So we are back to this, and now what I'll do is, so here you need a bit of code knowledge to understand what's kind of happening, because you might get confused, like, okay, what is timer layer, what is retry layer, what is all of this? But essentially these are some, so timer layer captures how much time a store method takes for Grafana. Retry layer is some retry logic if your transaction runs into a deadlock. But here is where your actual SQL query runs, right? Because you can see from here, you're directly doing that DB exec. So I'll select this and I'll select this, and then I'll go into P, right? So we looked at top, we looked at graph. Now I'll look into P. So in P, you can see the exact line number and how much that flat and cumulative thing, right? So here we can see that, okay, app notification.go 283. So let me open this. Hopefully this is big enough. So here you can see, okay, app notification dot, this is line 283, right? So here we can see that, okay, this is spawning a go routine in a loop, right? That means now this is starting to make sense. When it's an at all mentions, that means like, okay, this will spawn that many number of go routines with how many number of mentions were there. So if a channel had 50,000 users, this would spawn 50,000 go routines, right? And each go routine is a database call, right? So now it's starting to make sense that, okay, that maybe there are too many database calls happening, which is causing allocations somewhere and causing the problems, right? But we have a slight idea, but we don't exactly know where is the allocation coming from. So the next step is to look into the actual database call. So what we'll do is we'll go way down here, we'll just go to this, and then we'll do peek with this, right? So now we know that, okay, this is where the majority of the allocation is coming. So PQ con.go 1014, this one. So here we can see that, okay, like this is the make statement which is causing all of these allocations, and all of this is coming from this query. So you have 10,000 database calls all concurrent hitting the database, and each database query makes this allocation. And when you have like 10,000, 50,000, however, then that causes this spike, right? So this was basically this issue. Now I covered peak. You can also look at source. Source, you have slight question marks here because sometimes like it really depends on the debug data available, and sometimes it's useful, sometimes it's not. So, and disassemble, nothing is found. Yeah. So sometimes it really depends on how much of the debug symbols are available from the binary when you calculate, when you generate the heap profile. But in general, like, so this UI is like the same UI shared between CPU profiles and heap profiles. So sometimes some options are useful in CPU profiles, some options are helpful in heap profiles. So this was case number 1. So now let's look into another case. So this case was, so here we are looking at something. So we had an incident in community where suddenly we would run into memory spikes, right? Same as usual, capture a heap profile and then start to analyze that. So what do we see here? We see like a lot of things, but still following that initial approach of following the arrow with the most widest and most thickest arrow, we see that, okay, something is going on here. Now, if we take a look at the top view, so we can see that, okay, create post, then run multi-plugin hook, right? So we can see that, okay, something is happening when we are creating a post and run multi-plugin hook. That means we are some plugin related stuff, we don't know, right? It's just like, this is what we can see from here. And then okay, this is interesting, message has been posted. So we know that every time you post a message, there is a plugin hook called message has been posted, which posts the message to all of the plugins, right? So we can see that, okay, something related with that, right? There is gob encoder, something is happening, but we are not exactly sure because there are other things also here, right? We're not exactly sure what's happening. So in this case, what's helpful is the flame graph. So flame graph is another type of tool wherein you can see what portion of the, so if it's a heap profile, it will show you what portion of the heap was captured by what function, what stack traces. And if it's a CPU profile, it will show you how much time was spent on the CPU by a given function, right? So now with this, the stack trace is much more clear. We can see that, like, okay, this one is cache, right? Okay, it's expected that LRU cache will store something. So probably this is not the main issue. The main issue, what's happening is here. So we can see that create post, run multi-plugin hook, some sync map, then message has been posted, and then RPC client call. So that means in the RPC call where we are sending the data to each plugin, that's where it's going wrong, right? Okay, now we have slightly better idea. So now let's go back to the graph again and let's take a look at let's take peek, right? So, okay. So create post app.post 330, right? Run multi-plugin app.post 320. So let's take a look at the app post. Post 330. Let's see. Okay, probably this was a previous version, so line numbers won't match exactly. But we know that it's in the message has been posted hook, right? So has been posted, right? Okay. So this is from where the allocation is coming, right? So if we look into this one, message has been posted, and essentially you need to look at the, sorry, I have changed branches, so my auto completion is not working. But the issue is that, so we've kind of found out from where the issue is coming, but we don't know exactly what is causing this, right? We know that we are creating a post, and then there is a plugin hook called message has been posted, and most of the allocations are coming from there, right? Message has been posted, and then it does some RPC calls, and then it tries to encode the struct. So at this point, it's kind of up to the developer. So I had to look at the past commits and see what changed, and then we figured out that the permalink preview feature, what it did was it kind of embedded the preview image inside the post struct itself, right? And if you are embedding an image is like a big byte slice, right? But what this RPC call will do, it will marshal the entire post, and then it will send it down the wire to all of the plugins. If you have 20 plugins, and if you have a post which contains an image, let's say it's like 10 MB, right? Or let's say 500 KB. So it's 500 KB into 20 for each post. Now, if you have multiple posts happening containing preview images, that means you can understand that where the problem is. So we decided that, okay, plugins need not have access to the preview post. So we removed the preview post. We actually, when calling this plugin hook, we cloned the post, we removed the preview from the post, and then we're sending it to the plugins. So this was the second case. Now let's look at a third case. So this is a CPU profile, and this CPU profile is from our community server. This is not taken during any issue or something. This is just, regular CPU profile. So every Tuesday we have automation that every Tuesday a bot goes and takes CPU profiles and posts it to a channel, so that our team is aware of the performance, as in, like, if we suddenly see some function taking a huge part of the stack, then we know that, there is a performance degradation here, and we need to look. So this is how if you run Mattermost, it's not doing too much things, and if you take a CPU profile, this is what it would typically look, right? And so we can see that, most of the time is spent handling HTTP requests, which is kind of expected. Search channels, yes, Elasticsearch, it's doing things. And if you take a look at the flame graph, this is what your typical flame graph looks like. So there is nothing like nothing stands out. You can see that, search on channels is taking a lot of time, but yeah, it's expected because it's doing a search. So it needs to send out a request to Elasticsearch. It's doing some decoding, encoding, that sort of stuff. And we can also see this one. This is basically your garbage collection. So when you see things like runtime, that means you know that, the Go runtime is working. That means there's not much application type of code working. That means things are kind of good, right? And yeah, we have this is your plugin library. So basically things are kind of idle. There's not too much going on. And yeah, I just wanted to give you an idea of how does a profile look when there's not too much happening, so that you can get an idea of how a normal profile looks and what an abnormal profile looks like. And and if you do a top here, so you can see see the maximum amount of time is spent doing syscall, right? Which means that like, okay, these things are normal because you would want to avoid as much as application time as possible. Doing syscall is what is expected, right? Yes, a lot of time is going into compression, decompression, ingestion, encoding, and you can take a look at peak. So peak, if you don't filter by anything, then it will just give you all the things. Like it's a huge thing. So let me see, disassemble, nothing. Source is the same thing. Yeah, not much there. So source disassemble, not too useful, but yeah, top graph, flame graph, peak are useful. So yep, that's about it. Any questions?
Neva, can we see the flame graph again? Just one example.
Mm-hmm.
Okay, so what this is. So at a course level, how do you think about what's going on here? Like in terms of like you go row by row.
No, so flame graph. So ignore the colors. Okay, the colors don't mean anything. Colors are just there to like for you can easily distinguish by the eye. What you should look for is the width of an item, right? And these are kind of proportional. So if you consider root, see if root is given as 100%. So if you 100% and 2.34 seconds. So if you consider the total time as 100%, then you know that HTTP conserves, so 47% of the time was spent in serving HTTP requests, right? So that's how you figure out where the majority chunk of the time is being spent, right? And here you can see that, okay, in garbage collection marking, 9.4% of the time is spent. So now if you click on this one, then this one will become the top item. And so essentially here, the root was the 100%. And if you click on this one, this becomes the 100%. And then the items below that get spread out proportional, right? So if this is 100%, if it's 47% at the global level, but it's 100% when you click on that, then you can see that like, okay, now under this, serve HTTP is taking the majority chunk. And this one, what this one is doing is just like the compression and decompression, right? And so if you remove that compression decompression part, you can see that majority of the time gets spent here. So here is where you can see that like, okay, search all channels is taking this much time, get channel members for team for user. These are your every API calls, right? And you can see that like, okay, you can actually drill down to each and every API call and see what is going on inside that. So if I click on get user statuses by IDs, I see that this is calling this app method, and this is asking the LRU cache, and it's doing a bunch of marshalling and unmarshalling. And sometimes if there is a cache miss, then it's calling the database, things like that. So basically what I would do is like, first I'll take a look at here. And then if I don't see a big item standing out, right? So if I go back to this one, right? Post preview Marshall. Now, if I take a look at a flame graph for this one, then I can see that like, okay, this whole big chunk of item is just causing the majority of the allocations, right? So I know that like, okay, this is the one which is causing the issues, right? Because I know like this is the LRU cache, which is not too much of a problem, but this is the main problem. But if you compare the previous one, you could see that like, okay, there's nothing weird standing out, as in like the majority part is spent handling HTTP requests, which is what you would normally expect. So yeah.
Okay.
Cool. Yeah. Any other questions? Anything? I think, yeah, I explained most of the things. Yeah. So yeah, just to give like a brief recap, always use this mode, HTTP mode, and then you need to follow the boxes with the thickest arrows, and then either look at the flame graph or look at the top, and when you kind of finalize on which are the things which you feel like might cause the issue, then just select those items, and then you can do a peek. Then it will give you those exact line numbers. And yeah, at this point, this is more than good enough. Then you can just if you tell the developer that, hey, I can see most of the allocations are coming from here. Yeah, then they can easily look back through the commits and see what is causing the problem.
So just a question on engineering expectation on us. So now are we thinking the better way to move forward, collect this data, analyze it like we've done here, and then send it off to you guys once we've got to this point?
No, not at all. Engineering can do all of this. This is just you guys wanted to know how to analyze profiles.
Yeah.
Okay. I love this. I want to do this, but I just wanted to make sure I have my expectations right.
Yeah, of course, yeah.
So, but in that regard, sometimes we would love to be able to jumpstart this process. Is there something that the more sophisticated customers can do to help with this? Conversely, I mean, is it how automated can it be? Is there any way to, I don't know, is there anything that needs to be redacted out of this? Doesn't look like it.
No,
obviously names, but
yeah, this is just code. There's no, so profile will just capture what are the function calls. It never captures what is the data passing through those functions. So there's nothing to redact. But yeah, the major takeaway from this is that whenever there is a spike in CPU or whenever there's a spike in your memory, you need to train the customers and tell them that whenever you see spikes in CPU or memory, please run this command, right? If it could be automated depending on what sort of monitoring is put in place. So typically what would happen is if you have Prometheus or Grafana set up, in Grafana you can set up your alert thresholds. So if your memory goes beyond a certain alert, then you can create a post webhook or things like that, and then in that webhook you can do whatever you want. Actually, this the Los Alamos customer, what they did was they wrote a cron job wherein it would periodically poll the Prometheus metrics, and if the allocations, it was for the database connections, but essentially it's the same idea. So what they did was they created a script which polled the Prometheus endpoint, and whenever the number of database connections exceeded a given number, they would run this heap profile command, right? So something like this. It depends on the customer. Depends on what sort of monitoring they have. But essentially, if they're able to detect something, then raise an alert, and in that alert, they can run whatever code they want. So yeah.
Okay.
Cool.
Thanks, Agniva. So this class, in terms of the class of problem, this is really bounded. But besides seeing out of memory, is this class of sort of probing and solution? I guess you can look at high memory. It doesn't have to be an out of memory. It's just why is the memory high, right?
Yep.
Oh, okay.
Yep. So things like memory leak as well, right? So let's say that if suddenly you are seeing that memory is slowly increasing, and it's never decreasing, right? That means there's a memory leak where we are not releasing the memory. So anything to do with memory related, and the same thing, I remember we had issues with CPU spikes when LDAP used to run, right? And same things like that. So whenever an LDAP would run, capture a CPU profile, then look into okay, what is running in the code that is causing the spike in CPU, right?
But the CPU profile and the steps with the CPU profile analysis are entirely different from what you've taken us through, aren't they? I mean, there's maybe some overlap, but
You can load the same profiles with the same tool and look at them.
Yeah. So the profile that I showed you last, right? So this one.
Isn't one working with the heap and the other is working with?
Yeah, it's the same tool, same command, exact same command, but it kind of figures out which is the CPU profile, which is the heap profile. So this is a CPU profile from community.
Right. Okay.
The exact same command, exact same UI, exact same thing.
Sure.
So
okay.
This is a CPU profile. Sorry, this is a C profile. CPU profile. You can do graph, flame graph, exactly same things. But this will tell you how much of the time is spent on CPU, and the heap profile will tell you how much allocations or how much of the heap a given function is taking.
Oh, I see. Okay.
Yeah.
So flame graph, peak, all those sort of things you drill down into, source, whatever. That it's just the measure that it's with respect to. It's memory versus CPU. I got it. Okay.
Mattermost CPU, but in the other profiles you will see Mattermost. This one, Mattermost in use place.
Got it. Okay.
The UI is exactly the same.
Okay. Cool.
Cool.
Again, very, very useful session. Thank you, Niva.
Yeah, I'm just running through some steps locally just to see what I can generate, and it's interesting even on a box that's performing quite well. It's just good. Yeah, thank you. Very useful stuff.
Yeah. So I'd recommend to just capture heap profiles in your own local setup, heap profiles or CPU profiles. Do something very CPU heavy, right? And then capture a heap profile. Then see, can you see the function?
Yeah, that's a good.
Right?
Yeah, I'll get the CPU hammered and see what's going on. Good idea.
Yep. Do all of that.
Cool. Thanks, Agniva.